The kinematics problem, and this one's a little bit different because we're starting all the way back at acceleration. So we're assuming, or we're given the acceleration is t over 10 minus 3. And if you remember that we start in position, the derivative position is velocity, so v of t, and the derivative velocity is acceleration. So we're way over here. And the end of the question says to find the total distance. So we got to go back to velocity, taking into account that the initial velocity is 45 meters per second, and then we got to go back to distance traveled. So if a of t is this, then v of t is, take the integral, t squared over 20 minus 3t plus c, and then we can plug in our initial values. So 45 equals 0 squared over 20 minus 3 times 0 plus c. So 45 equals c. So then we have v of t equals t squared over 20 minus 3t plus 45. That's our velocity. So then it says we need to find the distance traveled in the first minute. So these are in seconds, so we need to go the integral from 0 to 60 of t squared over 20 minus 3t plus 45 dt. So this will be t cubed. If I bring down that 3, I still need a 20, so that should be 60 minus 3 over 2t squared plus 45t from 0 to 60. So if I plug in 60, I get 60 cubed over 60 minus 3 over 2 60 squared plus 45 times 60. And if I plug in 0, the whole thing is 0. But let's just put it there, make sure we always do it. Okay, where's my calculator? Let's just plug this in the calculator and find out what this is. So 60 cubed divides 60 is 60 squared minus 3 over 2 60 squared plus 45 times 60. And that's 900. So this is saying they went 900 meters in the first minute. Let's go over to the calculator and see if we can do some of this stuff with the calculator. All right. So here's the first function. Here's the acceleration. Looks like this. It's a straight line. See right here that there must have been a zero velocity. No, sorry, zero acceleration. And then let's turn this one on. We can see right here there's also a zero velocity. So there was a point in which the train actually stopped. And then if we find the area, let's turn this one off here. If we find the area underneath the curve, second calc from 7 from 0 to 60 gives us 900, which is exactly what we saw. And there's your kinematics problem starting at acceleration.